Hi guys, good morning. It's another lovely Thursday morning. I hope you're all doing fine. I hope you've been having a great week. Okay, so today we're going to be looking at, we're having mathematics. Okay, and we're going to be looking at a new topic. But before that, you know the drill. Let's look at some tricks together. Okay, so now let's look at this trick. It's the name of the trick is distribution, and it's applied for multiplication generally. Now, for example, let's assume you want to do this is a simple one anyway. I'm just going to start from something simple. Let's assume you want to do 6 times 8, and you want to do it as easily as possible. You can just pick the bigger number and split that number into smaller parts. That will be easier for you to multiply. So for example, 6 times 8 is the same as 6 times 5 plus 3. Okay, then you can multiply each of these terms one after the other, and then um, you can now move on. So we should have something like this. Um, 6 times 5 plus 6 times 3. Okay, so instead of 6 times 8, you can do 6 times 5, 30, plus 6 times 3, 18, and that gives us 48. So if you check back, you see that, of course, 6 times 8 is 48. Now, this is a very simple one, but when you have very big numbers, you can apply distribution. Just pick the bigger number and then split that bigger number into smaller numbers and then multiply. So look at something like this. This is also not too big, but something like this. A two-digit number now, 16 times 5. So you pick the 16 and split it into two parts that are easy. You can see I used 10. I made sure 10 was one of my parts because 10 is a round number. You can also do that when you're doing your splitting. Try to split out a round number from that big number. So here we have 5 times 10 plus 6. 5 times 10, of course, is 50. And 5 times 6, of course, is 30. So that gives us 80. Now we know that, of course, 16 times 5 is 80. So what let's assume you're asked to do 75 times 12. You can apply the same thing. 75. Multiply each by 12, and that makes your work easier. Okay? So try it out. Try it out and see if you can use it in your daily multiplication, and see if you can, stop with the, using a paper and a pen, to solve, or pressing a calculator, using a calculator. Just try and see if you can do some of these things in your head and do it fast. It will help you to increase your mental capacity. So that's that for our mental matrix segment. We're moving on now to our topic for today. So today we're going to be looking at sequences and series. Sequences and series. But we're majorly going to focus on the first part, which will be to discuss the sequences. And then in our next class, we'll talk about the series. So let's start with sequences. Now, an introduction, a small introduction to our topic. What is a sequence? What is a sequence? In English language, you know the meaning of a sequence. Okay, something that follows a particular pattern, right? A sequence. Oh, there's a particular sequence that's being used here. You've heard that word before. So a sequence is in mathematics now is a collection of numbers that follow an organized pattern. Now, when you look at this set of numbers, you can figure out a distinct relationship between each of the numbers. Then you can say that those numbers form a sequence. Okay, those numbers form a sequence. There are different types of sequences anyway. Now, just look at this one, for example. Can you figure out what is the pattern here? What's the pattern here? Figure it out. Figure it out. It's simple. Okay, let me tell you. I think by now you should have figured it out. The pattern is that 4 is being added to each digit. So you have 5 plus 4, 9, 9 plus 4, 13, 13 plus 4, 17, and on it goes. When you see those 3 dots, just know that the sequence continues to infinity. Okay, so this is another example of another sequence. What's the pattern here? Can you figure it out? What's the pattern here? -1, -2, -4, -8, -16. Can you figure it out? Okay, let me tell you, you should have been able to think of something. Okay, but let me tell you the answer. It's a multiplication of 2. -1 times 2, -2, -2 times 2, -4, -4 times 2, -8, -8 times 2, -16, and on it goes. Okay, so now Each member of these sequences that we've looked at is called a term. We have the first term, in that first case, which is 5, the second term, which is 9, the third term, which is 13, the fourth term, which is 17, and so on and so forth. Okay, and so on and so forth. So each term, each member of the sequence is called a term. Now, let's take an example. What if you're asked to find the first 4 terms of a sequence whose general term, that's the general formula for each term, is n plus 1 over 3n plus 2? What do? It's very simple. First 4 terms, so you're going to use numbers 1 to 4. Numbers 1 to 4 as the numbers of the terms. So we're going to substitute 1 first to get the first term. So to get the first term, first of all, the sequence is Tn equals, that's the nth, we call this the nth term. The general term is also called the nth term. So Tn equals n plus 1 over 3n plus 2. So T1 now, first term, we substitute 1. Okay, 1 plus 1 over 3 into 1 plus 2, and that should give us 2 over 5. Then for T2, we're going to substitute 2. 2 plus 1 over 3 into 2 plus 2 gives us 3 over 8. Okay, for T3, we're going to substitute 3. So 3 plus 1 over 3 into 3 plus 2 will give us 4 over 11. And for T4, 4 plus 1 into 3 into 4 plus 2 gives us 5 over 14. Now, you cannot write it out like this and say the 4 terms, or the first 4 terms, are 2 over 5, 3 over 8, 4 over 11, and 5 over 14. Okay, so that's that. Now, let's go further and talk about the types of sequences. Okay, now, sequences are basically classified based on the pattern by which they are generated. So, if they are generated from the difference between the terms, we call that something. If they are generated from the ratio between the terms, we call that another thing. So let's look at the 2 types we're going to be dealing with. Now, the first one is called the linear sequence or the arithmetical progression. Now, this deals with the difference. We call this the common difference. Now, the difference between a term and the term immediately before or immediately preceding it is a constant. And that constant is what we call the common difference. So that is what helps us to define a linear sequence or an arithmetical progression. The second type of sequence is a geometric progression or an exponential sequence. So now, what we use here is the ratio. Now, when you say ratio, it means you divide one term by the term before it, okay? So the ratio of a term to the term immediately preceding it is constant, okay? So that constant here is called the constant, the common ratio, okay? So we call that the common ratio. So in exponential sequence, we deal with the common ratio. In linear sequence, we deal with the common difference. We'll get into each of them now. So let's talk about the arithmetical progression, which is also known as the linear sequence. So if you see it being called the linear sequence, don't get confused. So the arithmetical progression now, as we've said previously, okay, we've said previously that the difference between the term and the term before it is constant. So let's talk about how to get the formula for the nth term. That's the general formula for any arithmetical progression. Okay, let's look at an example and see how the formula can be arrived at. So we know that common difference, we're going to call it that D, is a term Tn and the term before it. So Tn minus T of n minus 1. So we have T2 minus T1. It can be T3 minus T2. It can be T4 minus T3. It can be T5 minus T4. It can be anything as long as it's a term and the term immediately preceded it. Okay? So let's look at this example. So we looked at this example when we're talking about the introduction there. So 5 is the first term here, right? Okay, so T1 is 5. T2 now is 9, but we can express that in terms of 5. It's 5 plus 4. We can go a step further and say it's 5 plus 1 times 4, right? So 5 plus 1 into 4. I will show you the necessity for that. Now, T3 can also be expressed, that's 13, can also be expressed in terms of 5. So we have 5 plus 4 plus 4. That's an addition of 4 2 times. So that can be written as 5 plus 2 now times 4, right? That's 5 plus 2 into 4. I hope you're seeing the pattern. Let's do the next one. T4 now is 17. It can be written as 5 plus 4 plus 4 plus 4. So that's 5 plus 3 times 4. So that's 5 plus 3 into 4. Now, if you notice a pattern, you'll see that 5 is common to everything, right? And 5 is our T1, which is also called A. We use A. That means it's the first term. The first term is T1 or A. So you can see there's 5 in everything. And then you can see that we have um, 4. 4 in everything, right? Apart from the first term, we have 4 everywhere else. Now, 4 is the common difference, D in this case. Now, but you're also noticing that the numbers in brackets are increasing in steps of 1. 1, 2, 3, right? And each of them is related to the term in question. So for T2, you can see we have 1 in brackets. For T3, you can see we have 2 in brackets. For T4, we have 3 in brackets. Now, that gives us a general formula. So we can say that the nth term of any arithmetic progression can be expressed as Tn, where n is the number of the term, equals to A, first term, plus n minus 1, that's the number of the term minus 1, bracket D, the common difference. Okay? So remember that A is the first term, n is the number of the term, if it's the second term or the third term and all that. Then D is the common difference. So this formula is not far-fetched. It's not something that was brought up from the sky. It's something you can even see with your own eyes if you form a pattern with any arithmetical progression. So try to learn the formula and be able to recall it when you need it. So Tn equals A plus n minus 1 bracket D. Let's apply that to an example. So for example, you have a sequence here and you're asked to find the 40th term of the sequence, linear sequence 6, 11, 16, 21. Okay, so of course you need to write out what you have and then try to solve. So we have Tn as our formula equals A plus n minus 1 bracket D. Remember that our first term is A and A is 6. And then D, a common difference, is T2 minus T1. That's second term minus the first term. Or you can use third term minus the second, it doesn't matter, but let's stick with T2 minus T1. So D here becomes 11 minus 6, which gives us 5. So our D is 5. Now we are looking for T40, the 40th term, so T40. Okay, so T40, 40th term is 6 plus 40 minus 1 times 5. Number 6 is A and D is 5. So 6 plus 40 minus 1 times 5. So that gives us 6 plus 39 times 5. That gives us 6 plus 195, and that gives us 201. It's as easy as ABC. It's as easy as ABC, so that's that. Now, arithmetic mean. What's the arithmetic mean? Now, the arithmetic mean is related to the arithmetical progression, of course. Now, the arithmetic mean of two numbers, P and R, for example, is a number Q is that is such that is a number Q that's in. If you put Q in the middle of P and R, okay, you will get an arithmetic progression. That's just it. That's just the basic thing about arithmetic mean. So the arithmetic mean of two numbers P and R is a number Q such that when Q is placed in the middle of P and R at PQR, it forms an arithmetical progression. So that's just that for the arithmetic mean. Now, if you want to express that mathematically, you can say Q equals to P plus R over 2. So you know this already anyway. If you don't know it, you can know it now. So let's just see how that is applied to questions. So for example, they say insert three arithmetic means between 19 and 35. What are they saying in essence? They're saying put in three numbers between 19 and 35 in such a way that when you look at those numbers combined together now, they form an arithmetical progression. That's it. Now, but let's analyze. If you're saying you're going to put three numbers in between 19 and 35, how many numbers will they become altogether? I think that should be 5 numbers altogether, right? Okay, so that means 19 is going to be the first term, and 35 is going to be the fifth term, if I'm right. Since you said you want to put 3 numbers in the middle, right? So the 5 of them form an arithmetic progression, so 19 becomes the first term, and 35 becomes the fifth term. Okay, so we have T of n, as usual, is a plus n minus 1, close bracket d. So T1 is A, in this case it's 19, that's an equation 1. And then we have T2, T3, T4 as our arithmetic means, and then we have T5 as our 35. So but T5 is A plus 5 minus 1 into bracket D, right? So 5 minus 1 is 4, so T5 is also A plus 4D. Okay, now that simply means that since T5 is 35, it means A plus 4D is also 35. Now we have two equations. Follow me, we have two equations now. So we are now going to substitute equation 1 into equation 2. So wherever you see A, you're going to be putting 19 now. So we have 19 plus 4D equals 35. So 4D equals 35 minus 19, which gives us 16, okay? And then if 4D is 16, then D is going to be 4. 16 over 4 is 4. Okay, so that's our D. Now that we have D, we can go ahead and get T2, T3, and T4. Now T2 is going to be 19 plus 2 minus 1 bracket 4. Now our D is 4 now, and we are using our formula for Tn. Take note of that. So 19 plus 4 will give us 23. T3 is going to be 19 plus 3 minus 1 into 4. So that will give us 19 plus 3 minus 1 is 2. 4 times 2 is 8. So 19 plus 8, which will give us 27. And then T4 will give us 19 plus 4 minus 1 into 4. So 19 plus 12 will give us 31. So our three arithmetic means are 27, 23, 27, and 31. So it's not difficult. It's not difficult. If you understand the concept, it's going to be easy for you to solve. Now let's move on to geometrical progression, which is also called an exponential sequence. Now we talked about this. We said the ratio of the term to the term immediately preceding it is constant. So in this case, we're talking about a common ratio. So let's talk about how to get the nth term. Now, for example, before we go to the example, we already know that Tn and Tn minus 1 are terms that are following each other. So the ratio here is Tn over T of n minus 1. Now, as we said, it can be T2 over T1, or T3 over T2, or T4 over T3. It can be any two terms in the geometrical progression. Although we like to stick to T2 and T1, but in cases where you do not have those, you can use something else. Now look at this, 6, 12, 24, 48. Of course, our ratio here is 12 over 6, T2 over T1, which is 2. Common ratio R is 2. So T1 is 6, and that's the same thing as A. T2 is 6 times 2, and that is the same thing as AR. Take note that R is 2. Now T3 here is 6 times 2 times 2, okay? That's 6 times 2 squared. That is AR squared. Okay? Remember that A is 6 and R is 2. A is 6 and R is 2. Don't forget that. Then T4 is 6 times 2 times 2 times 2, which is 6 times 2 cubed, which is AR cubed. Because A is 6 and 2 is R is 2. So we can see a pattern emerging here. So our nth term of any geometrical progression can then be expressed as T of n equals to AR raised to power n minus 1. So this is a general formula where A is the first term and n is the number of the term and R is the common ratio. Okay, so you can see that we looked at the pattern and we saw that there's a recurring pattern where the power of the ratio R is always 1 less than the term in question. You can see the power for T2 there is 1, power for T3 was 2, the power of R for T4 was 3. So we looked at that pattern and we said, okay, T of n is usually AR raised to power n minus 1. So that's how the geometrical progression formula was obtained. Now let's go a step further and see how to use it. So let's assume you have this question. The second term of a GP, geometrical progression, is 35, and the fourth term is 875. You have to find the first term and the third term. How do we do that? Okay, so tan t of n is ar raised to the power n minus 1. So t2 is 35. So t2 is ar raised to the power 2 minus 1, which is ar. So ar is 35. Then t4 is ar raised to the power 4 minus 1. That's ar cubed, and that is 875. Now we're going to work some kind of, go do some kind of calculation here to get our R. Now, since AR is 35 and AR cubed is 875, let's divide the two. We're going to divide AR cubed by AR. So if we do AR cubed over AR, it gives us 875 over 35. Now, if we do AR cubed over AR, A cancels out, right? R cubed over R is R squared. R cubed over R raised to the power 1 is R raised to the power 2. So R squared, 835 is 25, so R squared is 25, and R is 25, square root of 25, that's 5. So our common ratio here is 5. That takes us a step further now. The first term is what we need to find. But remember that AR is 35. So if AR is 35, it means that A will be 35 over R, right? If AR is 35, so 35 over R is 35 over 5, so our A is 7. So our first term is 7. We've gotten the first part, and our first term is 7. But we have to also find the third term. So T1 is 7. Now T3 is A raised to the power R, sorry, AR raised to the power N minus 1. So that is 7, okay? That's our A is 7. Our R is 5. So 7 into 5 raised to the power 3 minus 1. Just take it step by step. 7 into 5 raised to the power 3 minus 1. 3 minus 1 is 2. So that gives us 7 times 5 squared. 7 times 25. And our T3, our third term, is 175. 175. So that is our first term. T1 is 7 and our T3 is 175. Now let's move to geometric mean. We talked about arithmetic mean. Let's move to the geometric mean. Now the geometric mean of two numbers, x and z, can be said to be y, okay? So if three numbers x, y, and z are in a geometric progression now, the geometric mean can be expressed as y, this is geometric mean like I said, equals to square root of x, z. Okay, equals the square root of x, z. So let's just look at something that, might not necessarily apply and might not necessarily use the formula for, but let's see how to insert geometric means. So insert two geometric means between 12 and 324. Remember that they must be in a geometrical progression when you insert them. So let's just pick two numbers. Of course, if you insert two geometric means, it means 12 is the first term and 324 will be the fourth term now, since they are going to be 4 terms altogether. So Tn, remember that Tn is AR raised by n minus 1. So T1 is A, which is 12. That's our first equation. Then the two means, of course, are T2 and T3. And T4 now is 324. But T4 is AR raised by 4 minus 1, which is AR cubed. So AR cubed is 324, right? We said that C4 is 324. So the same thing we did before, we're going to use equations 2 and 3 and divide them. So we're going to divide equation 2 by equation 1. So AR cubed over A equals to 324 over 12. So if we divide, we should have R cubed equals to 27, and R will be cube root of 27, which is 3. Okay, which is 3. So now we can get T2 as AR raised to the power 2 minus 1, which is AR, just AR. So A is 12 and R is 3. 12 times 3 is 36. Then T3 is going to be AR raised to the power 3 minus 1. That's AR squared. So that's 12 times 3 squared, which is 108. Okay, so which is 108. That is our T3. So our two geometric means are 36 and 108. Okay, so that's that for the geometric mean. Okay, so let's quickly take a summary and then we just stop there for now. Like I said, in our continuation class, we're going to be looking at series. So we talked about sequences and we said there are a set of numbers that obey a certain pattern, follow a certain pattern. Then we said there are two types of sequences. We have, we're going to be looking at anyway, we have linear sequences and arithmetic, linear sequence, which is arithmetic progression, or exponential sequence, which is geometrical progression. There are other sequences that do not necessarily fit into these two specific categories, okay? So there are other types of sequences. But for these sequences, we said arithmetic progression has what we call the common difference, which is the fact that a term and the term before it share a common difference. Then we also talked about the n term of an arithmetic progression, which we said is t of n equals to a plus n minus 1, bracket d. Okay, then we talked about the geometrical progression, which is the exponential sequence, and we said in that particular sequence, what we have is a common ratio. The 10 and the 10 before it are the share a common ratio. Okay, so we now said that the common ratios are, and then the nth term of a geometric progression is t of n equals to a, where a r is by n minus 1. Then we talked about the arithmetic mean, which is q equals p plus r over 2. And then you can insert as many numbers of arithmetic means as you can in between two numbers, as long as they form a geometric arithmetical progression. We also said that the geometric mean has a formula of y equals to square root of xz, and you can also insert as many geometric means as you are asked to in between two numbers, as long as those numbers now form a geometrical progression. Okay, so I want you to take note of all these things we've said and try to apply them to further questions on your own. I'm going to give you some to do anyway. So look at these questions. Try to find the first term of a linear sequence is 3, the 8 term is 31. So I try to find the 10 term here. Then insert 3 geometric means between 2 and 81 over 8. The third term and 8th term of the GP are 1 to 8 respectively. Find the 7th term. So try to solve these 3 questions. They're not difficult. You can just pause the um, pause the video and see if you can solve them quickly. You solve them as quickly as you can and see if you're able to get them. If you're able to get an answer and you think, okay, you have the correct answer, give me feedback in the comment section and let me see your answers. Okay, so you can also visit quizzes.com if you want and play some games on sequences. Search for some games on sequences and see how well you can play them. So remember, if you have any feedback for me, leave them in the comment section. Anything you want further explanation on, clarification on, you can leave them in the comment section. If you enjoyed the class, you can also leave that in the comment section, okay? Then remember to like the video, also share to your friends to help them with this topic. And don't forget to subscribe for weekly updates. It was amazing seeing you guys again. I hope we have more fun together next week. So have a lovely day and take care of yourselves. Bye.